Welcome to the configuration and getting started tutorial for Gravity Engine 2. So what I have here is a Unity project where I've loaded Gravity Engine 2, and in addition I have manually loaded, although the Unity Asset Store dependencies should do this for you, some packages that Gravity Engine 2 requires, specifically Burst, Collections, Mathematics, and TextMesh Pro. TextMesh Pro is only needed for the sample scenes. The others are needed for all the scenes. So if we look at the Gravity Engine 2, at the top level we have Editor, a README, Runtime, and Samples, which is the recommended package format. The examples are all in samples. There's a Tutorials Getting Started, and the Hello World equivalent for Gravity is called Hello Orbit. We'll open that scene. The first thing to note is that in all of the demonstration scenes, there's an object, usually at the top or near the top, called GE2 documentation. And what that does is it gives you a little bit of context in this scene info block, but very importantly, it has a URL to the documentation and a button you can click on to open that documentation. And boom, we're over in the documentation, and this is actually a description, and then a little bit of context about how the objects in the scene fit together in this case. And we'll come back to that shortly, but first let's talk about what the scene does. So back to the scene. If we want to just go ahead and press play so we can get a view of what's going on, we have a central body. We have a ship orbiting this body, and it's orbiting in an ellipse. And we're seeing the full path of the ellipse. So let's, in order to walk through the components of this scene, build this up completely from scratch. So we'll start a new scene. Don't need to worry about that guy. So what we'll do first of all is take advantage of a camera that always looks at the origin of the scene and can move around it with arrow keys or mouse movements. So in the prefabs under samples, there's this GE2 camera. So we'll grab that. We'll ditch the camera that was already there. And now we'll go ahead and start to put some stuff in the scene to do Gravity Engine 2 type things. So we'll create a top level controller. So in Gravity Engine 2, the scene components are usually prefixed with GS, so we'll add a GS controller. And what this controller will do, it will create a class called GE Core, which I'll show you a little later in the block diagram. And that's the entity that manages the bodies and can be queried to determine where the body is at the current time, and can be told to go ahead and evolve the bodies for a particular amount of time. And that can be used as a standalone script without displaying or any mono behavior add-on. GS controller is the scene wrapper for that kind of thing. GS controller determines what the things it's going to move around using gravity or propagators are by searching for GS bodies, and those can be searched for either as children of this object or in a list or anywhere in the scene. There's a bunch of other options here that are described in detail in the documentation, but for the purposes of just a hello world getting going, we will leave that for later. Now the controller doesn't inherently display anything. One of the key points in Gravity Engine 2 is the physics bodies and the display bodies are kept separate, so that if you want to have multiple display bodies for one physics body in a couple of different views, like a mini map or a 2D map of the surface of the Earth plus a 3D map, that's all much simpler. So we're going to add a GS display component. This is what's going to actually move bodies around in the scene based on the physics evolution that happened in the GS controller. This also allows you to change the scale of the display, and the position and rotation work as you would expect. The scale is controlled here because we want to scale uniformly in all three directions. So now we can start to add objects. So we'll create one called Planet. And in order for this to be something that the gravity scene controller can find and add to the engine, we'll add a GS body to it. And now there's a whole bunch of options for how to specify the physical attributes of this body in the physics, in the worldview. So we have a choice of the propagator. Gravity in this case is fine. We could also have it move according to Kepler, p Kepler, or other propagators if it's propagating around a central body. We could use a table of values, which is an ephemeris table, and we can specify the mass. So for the planet, we're in dimensionless units, so we'll just say 1,000 as a kind of arbitrary scale. And the position in this case, we provide the initial data for this body as absolute position and velocity, and we'll just leave the values as 0. So that's all okay. And then we're going to add a ship to that. So we'll do much the same thing. We'll create empty. We'll call it ship. We'll add a GS body. It's perfectly okay for this to be massless. In fact, it's pretty normal. You wouldn't normally worry about how hard the ship is pulling on the planet, so that's a good choice. And here we're going to specify the orbital details of the ship. So we could provide an RV relative to the planet if we had some real world information about the state of the ship. But if you want a particular orbit, it's generally useful to talk in the language of classical orbital elements. So we can talk about maybe an axis of 20, maybe make it not quite round, so an eccentricity of 0.2, and we could even tilt that eccentricity around a little bit by making the argument of perigee 30. Now, we haven't done anything that will tell GS display what to do with these bodies. So that's the next step. These GS bodies are found by the controller. GS display looks for a separate component, which is called GS display body. So if we attach this to an object with a GS body, it automatically figures out that that's what we want. We also need to add some object we can see. So let's add a sphere. Maybe make it, 5 big. So there's our sphere. Then if we go to the ship, we can do a GS display body. It automatically knows that it's tagged to the ship. And then we can add to the ship a 3D object, just arbitrarily a cube, so we can see what it is. And notice that in the scene, we have now put the cube based on its orbital information. And at this point, we can go ahead and press play. We've got all the core components we need. We have GS bodies for the ship and the planet, and we have GS display bodies for the ship and the planet. So there we go, we've got our ship moving around the central planet, but we're not seeing the orbit. So how do we make that happen? So we'll just pause here, or sorry, disable the scene. So, no shocker, it's called GS display orbit. And if you drop it in, it automatically figures out that this is a body. It checks that the parent is the center, which is the common way to use this. And it figures all that out. And then when you're in editor mode, it also actually shows you a gizmo that will illustrate the orbit. The one thing we have left to do is it needs to be told what line renderer to use to display the orbit while we're running. So we're going to add a component line renderer. We're going to make its width probably about 0.4. And it will automatically look up the orbit information and populate that line renderer when the scene plays. And there we go. And now if we want to make that orbit look a little more elongated, we could change it to 0.4. You can see here in the scene it's changing. We'll go up here. And we have a more elongated sort of off-center orbit. Now, one of the things we didn't talk about is how quickly in the game this body will orbit the center, and that is in the GS controller here. And we can set that scale a couple of ways. If we look in the units and scale section here, we can set the scale per orbit, or we can give some absolute value. So if we want the game seconds per orbit to be 60, then we need to also tell it what the typical orbit scale and what the typical mass scale are. And currently our orbit, we've got it set for an orbit scale of 100. So an orbit of 100 would take 60 seconds, but our orbit here isn't 100, it's less than that. So if we click on auto set scale, it actually checks and finds the scale of the orbit we're using. It finds the mass of the central planet that we're using. And now if we press play, that orbit will take 60 seconds. And you can see it's definitely moving much slower. If we want that orbit to take 10 seconds in our game, we can make that happen too. Another useful little feature in GS Controller is down at the bottom here, debug keys. So let's make it go back to 60 seconds per orbit. So the debug keys allow us to do press a D for pump for dumping information to the console, which can be useful for figuring out what's going on. A P for pause go, and 1 to 9 for time zoom. So if at 60 seconds per orbit, it's kind of slow. If I press 3, it goes a little faster. 5, 6, 7, back to 1. So you can dynamically control the game time evolution speed with that checkbox checked. So while I've described the components and how they relate, it's useful to sort of see that pictorially. So there is a how is that working that will talk you through what's going on. But in broad strokes, there's a GS controller here that's looking at a bunch of GS bodies. And then there's a GS display, or more than one of them, which is then responsible for certain display bodies and display orbits. The controller interacts with the core code, and that core code actually uses GE Physics Core, which can handle all kinds of evolution kinds and numerical integration, which is described in more detail in the documentation. And these guys are not mono behaviors. They're just straight up C# classes, so that if you have code that wants to do some hypothetical modeling of orbit paths and interrogate what's going on, do a little bit of route planning, you can do all of that without having to create objects that do mono behavior stuff, which is fairly handy. That's our introduction to Gravity Engine 2. There is lots of online documentation here, lots of sample scenes, and other videos that you can explore as you learn to use it. As always, you can send support emails or questions, comments, and suggestions for future work to nbodyphysics@gmail.com. The email address is in the README. Thanks.